Hello and welcome everyone to a short tutorial about interactive objects. And when I say interactive objects, I don't mean objects the player can interact with, but objects that can interact with each other. To explain what I mean, I will make a save with a keypad and a keycard. And if you come close with the keycard to the keypad, if you swipe it over there, the save will unlock and open. So you use an object to interact with another object to essentially do something. It's not pressing E and then something happens. It's doing something like putting a card somewhere, or I don't know, think of Indiana Jones pulling up a golden statue and then a great ball starts rolling after you. So I'm here in Magica and I will quickly make a save. I will just make it a box with four, with all walls. So attached, this is my save. I call this save. For the sake of simplicity, I will cut out the door of the save like that. I hope that's symmetrical in some way. So maybe this. Yes, I will cut it out, go upwards, paste it in, go inwards, and then I will clamp it. And yeah, I will change the color to a lighter color so I can see it's a safe door. So this is the door of the safe. And now I need a keypad. For this, I'm just copying the door again, pasting it and pulling it one forward, going in there, erasing it and making a box at here, I think, like that, just like that. This will be my keypad, and I will paint it in a color I have prepared, and the color is the color is emissive material. In Magica you see it glows. It's a bluish glowing emission power thing. So this is my clamp it, and this is my keypad. And well, if I have a keypad, I need a keycard, and I will make a keycard from the keypad by erasing it and making it a bit smaller on each side, so 4 to 6, then attaching plastic and maybe painting a line of grey plastic here, so we have a keycard. Save that to a folder in my create, to the custom 6 folder. I already have a save box here. I overwrite it with save box. Yes, I want to replace that. And now you can see I have all these objects here. For the sake of simplicity, I now switch to my editor. You can do everything what I show you in XML. It's just positioning, and this is way more easy in the editor. I will now position this save in my scene by going to the importer, importing from the custom 6 folder my save. There it is, and it has the keycard here. And save, I'm copying out everything from under the library here. SaveBox is a library in some case. If I export this, it will export the whole save. So I can choose to export all this with a floating keycard here, or I make all these things single elements that I can handle. And this is what I do. So the keycard is here. I just quickly rotate it around 90 of Z. No, I don't. 90 of X and put it on the ground like that. And then I have to go to the door and say to the door, you are a dynamic object, so it can move. The keypad should be, I don't know, should it be dynamic, or will it connect to the door this way? We will see. So I have to save the keypad, the keycard. I go to my exporter. I already choose the create folder of my Teardown installation to be my create folder. The level name is custom 6, the output file name custom 6 XML. I just use the main Lua, don't make anything fancy here, and then I export it to Teardown. And if we have a look in the XML, it is like that. It has an unbreakable Vox box, which is the ground. Then it has the safe, the door, the keypad, and the keycard. And the door is dynamic and nothing else. The keycard is a bit rotated and it's placed on the floor. So if I go to my level, which I have opened here, and restart it, I should be able to see the safe starting right on top of the safe. There is my keycard. It is not dynamic. Oh, I didn't make the keycard dynamic. I made the door dynamic, which is here. And okay, I didn't make the keypad dynamic, so it is frozen where it is. That's okay for now. We switch that now. We make the keypad also dynamic. Then we make the keycard dynamic, so we can grab it. And then we have to glue the dynamic keypad to the door. And to glue something to something, you can use joins. You can also do this in other ways, but I will use my joins here. Taking a ball joint, putting it slightly into the door, halfway, and putting it left down here, and then putting it, pasting it, putting it here. So it freezes this. Should freeze this in place. This is not true. It is. I think I put a joint here and a joint there, so it freezes in place. I will show you in a second that this won't work. I need another joint here to make the door actually be able to open. So a bit more, no, a bit more in there, thank you. And another one here to have a door. So if I just export it, we will have a very funny keypad right now, because I pinned it at a diagonal joints, and if I touch it, it should rotate around these joints. Now what you see here is things that are joined together can't collide with each other. So this pad is joined to the door, but it will constantly rotate. I could add a third joint now to fix that, or I can make one of the joints in not a ball joint. This will fix it too. As you see, those ball joints are already working, but like with the pad and the door can't collide with the safe because they are joined together. Now, the safe is oh, nice effect here. The safe, nice rendering effect. The safe is joined to the door, and the door is joined to the pad. So the door can't interact with the safe. The door can't interact with the pad, but the pad can interact with the safe. So you see, the pad stops the door from glitching. Yeah, it stops the door from glitching. If I push it hard enough, it won't stop the door from glitching into. But you hear the sound it makes. So what we need to do is prevent the door from rotating around here. Can do this with rotational values and make this pad stop to rotate. So I'm in a bit of a mood to make just where is it? Just a third one. So it freezes it in place now. This one goes in the center, so we have 3 points now here. These 3 joints keep this pad up. There are easier ways to do that, but why not? If I can glue it like that, I will do it. Export to Teardown to show you that it actually works. And you will see we have a door with a keypad that is not at all wobbling again. So, but it remains a very strange safe door. To change this, we go to the door and we make one of these joints not a ball joint but a hinge joint. Now, a standard hinge joint, I will show you this, a standard hinge joint, putting this down there and this joint away for a second, is orientated in a way that it pulls forward and backward the objects it is connected with. What I mean with that is the door will now fall on top of me like a truckload, the back of a truck. If I touch it, right now it can fall. Oh, I already rotated it, it seems. So it rotates around this spot from left to right. should have fallen in my direction. What's that direction here? This is the... Oh, this is the Z or the Z coordinate. Okay, so then it rotates like that because it always rotates around the X, which is this one. So it rotates around... no, what I'm talking. It rotates around Z right now. It always rotates around Z. So it rotates from left to right. To change that, to make it rotate in the right direction that we need, which is rotating, come on, get back there, which is rotating from inside to outside of the door, we need to turn it around by, I think, by 90 degree of X. Let's check if that's right. So it turns inside outside now. So it still goes up and there. That's okay. The hinge joint, and what we need to do with this hinge joint here, this little friend, is we say use limits, and the way it's orientated, we have to use minus 120, which is in our direction 120, and in the direction of the screen it should not rotate at all, so the door is frozen at the place where it starts. And if that holds true, the door should now be frozen. I can't pull it inwards, but I can open it up to 120 degree. There you see, at 120 degree it simply doesn't go further than that. And I can try to slam it into the safe, but it won't. Now it doesn't make a sound. That's not so nice. You can use a stopper in the safe to do this more in a soundy way, yes, to make a bump sound here or something like that. So it's a bit wobbly. You can adjust the rod strength to make the door, I think 0.3 might be a value. I don't know if the player is able to pull the door at all with a rotational strength of 0.3. But if he can, yes he can, but the door will be... Did I forget to export this? Hinge. No, it has no rod strength. I didn't exported it, or I didn't wrote it. Size. No, not the size. The rotational strength of 0.3, and again exporting it, having a look at the XML. Did it work? It worked. And then the door should be not that paper-light. Now you see, it's not floating around anymore. If I pull it or push it, it is a very strong hinge now. So I still can't pull it more than 120, and I can make it 0, but I want to make it shut and only openable with this keycard. To make this, I need Lua now. I can't do this in the editor. The editor was only for placement of things. I need to script it by Lua, and before I do that I use the editor one last time to give tags to the objects. And why I am doing this, giving an object a tag will make it accessible in Lua, so I can grab it there and do whatever I want with that. So the tag for the keycard will be simply keycard. The tag for the keypad will simply be keypad. And the hinge joint I have here gets the safe hinge tag. Safe hinge, it's not so cool to write it like that, but it's okay. Safe hinge, keypad, and keycard. So the first thing we want to do is to export this and have a look at the XML. And we see we have a joint called safe hinge. We have the keycard and the keypad. Now I group them together a bit. I'll show you why in a second. And I make a script called level/save.lua. Level is a placeholder, as you can see here and here and here, to the actual folder of the level, which is custom 6. So level will be replaced by the engine to level to custom 6. And then I place a save.lua inside the folder custom6. Now I here at the custom6 folder I already made the save Lua file, just create a new one, a blank one, and then we start there. And what we have to do in Lua now, even if you have never done scripting again, we have to write a function called init and end. Which this does is everything between those two lines, function init and end, will be executed, is code that will be executed at the start of the level, only once at the start of the level. And what I do at the start of the level is I grab my ingredients for my little recipe. I grab the keycard by writing find body keycard true and say this is the keycard. Now why do I write find body? Because the keycard here is a body tag. There are other tags like voxbox, joined, and we will just see in a second that joined can be catched in another way, but I want to have the keycard and it's a body, so I say find body keycard. Now why do I say true? Because these objects, these three objects, are not inside my script tag in XML. I can easily switch them inside my script tag by doing this. Now I have I have an inside of the script in the XML, and then I'm just copying that into the script. So the script has now private, if you want it, like private objects that are accessible within the script. It doesn't have to look for them outside of its own script, so I can skip the true, which essentially said, should I look outside of my script tag? Yes, true, do it. So now I don't say true, which says no, you don't do it, and you just look inside here. The keycard we already have. Now we take the keypad, and before doing anything else, we just stick with both of them, and we make a little function, tick df, which is another function that is built in, and it means it will be called every game tick, which can be more than 100 times in a second. It's not every frame, it's every processor tick, if you wanted to call it like that. So it's called 100 times a second, this function. And in this function we can do everything we need to check for a moment in the game. And what I want to do is I want to check if the keycard and the keypad have a certain distance to each other. Because if I use the keycard and swipe it over the keypad, they have to be quite close to each other. And that's what I want to check. If they are close to each other, then do something. So I just get the position of both objects, and then from the position of these objects I can compute the distance. I will do this right now. I will take the keycard position, which I can get by get body transform. A transform is an object that holds the position as well as the rotation of the object, the orientation of the object. Is it looking upwards, downwards, left, right, and where in 3D space is it? Is it 5 meters up, 6 meters to the left, and 7 to the front, or is it backwards 1 meter and down to 2 centimeters? That's what position in 3D space is like. So I say get keycard position is get body transform from the keycard, and then pos, because and another variable would be rot to get the rotation. I don't want the rotation, I want the position. And I don't need to forget the keypad position. That's the position of the keypad. So when are those, how do I compute if these are close to each other? I take the vector between them and take the length. That sounds a bit mathematical, but in easy words, it's just if I draw a line from the center of one object to a center of the other object in 3D space, if I take a bit of string and put it between them, so it's a straight string between the centers of those objects, this will be a vector. And I can just subtract the position of the keypad from the one of the keycard. This will yield the vector, the string that is stuck between those objects, and then I will say vec length, which is how long is this string, and this string is exactly the length of the distance of the centers of these objects, right? So if you hold a glass in your right hand and in your left hand, and you go and you make it so that you will attach a little string to it, and you pull them away from each other, so the string is very tight. That's the vector. And it's exactly the same length as the distance between those two glasses in your hands. So that's what I'm doing here. I'm taking the vec length, the length of the vector between those objects, and this is nothing more than the distance between the pad and the card. And that's a nice thing to do. Always name your variables so you can do something with it. Can't be too long, believe me. Now, I need a little condition here. I say if the distance between the pad and the card is smaller than 1.5, which is half a voxel, then I will do something. And what I will do is I will print a little message for the start. I will say HUD notification keycard is near the keypad. So, this is a little Lua script I wrote here in the save Lua. I referenced that from the XML by writing script file save Lua, level save Lua, and putting all the objects I need inside of the body. I didn't have to do that. I don't have to do that. I just can write true here, then I can pull the objects out of the XML again and place them wherever I want. But for the sake of computational costs, expenses, so it's easier and it's faster to compute if it's inside the tag, because it doesn't have to search around in the whole XML. So I grab the keycard, I grab the keypad, I grab the position of the keycard and the keypad, I compute the distance between those two, and then I say if the distance between the keycard and the keypad is smaller than half a voxel, 0.5, then we should see a string at the top of the string, a text at the top of the screen which says the keycard is near the keypad. Now, let's see if I made a mistake. Usually I make mistakes, so don't worry. There is my keycard, there is my keypad, the save is open, it's no problem here, and I put it there. And there, keycard is near the keypad. Now this message will vanish in a second, and then I can try it again if I put it nearly there. There, keycard is near keypad. So, nice and easy, but what we want is we want to shut the save and open it with the keycard. To do that, I will add another object in the scene, and I will add the... No, I don't need to add another object. I have the save hinge already. I will just shut the save hinge. And to do this, I say save hinge is find joined. Save hinge, find joined. Because this is a join tag, not a body tag. I say find joined with the tags save hinge, so I call it save hinge here. And for the sake of simplicity, I call it save hinge here too. And then at the start of everything, I say freeze this joint in its position. And hopefully I can do this with set joint, I think it's motor. Yes, set joint motor. And then I say save hinge. And set it to 0, which means nothing is applied, no rotation force is applied to make it 0. Now this won't work very good. It will be a difference. You see, I can do this with the door right now. And if I just write it like that, so setting the hinge to 0 each tick, so don't move. In each tick, don't move, I say. Then it will, I think it won't be enough. Because if I just pull here now, ever so strongly, you can see it will eventually come out. Even if I say it's not that fast anymore, but it's not near to closed. What I can do, I can check if a rod strength, a higher rod strength will fix this. If not, we will have to do another thing. Now you see the rod strength doesn't do anything good here or bad. It's just microscopic pulling here is just not realized by the motor as a rotation, and it won't do anything. By the way, I just said to the motor, don't rotate, little motor. I don't say close the door or something like that. What I can do is I can freeze the door in place. I can go here and say I have the door of the safe, and I give it another tag. Tags is door, and now I can access the door of the safe instead of the hinge of the safe. And I can say, give me the door of the safe, and then instead of setting the hinge, I'm at the beginning of the level, I'm saving the position of the door when it is shut. So I say door transform is get body transform right of the door at the beginning of the level. So in each round, each tick 100 times a second, I'm going to set the body transform back to that. So if the door is operated, it should snap back to its original state. I don't think this works either to keep the door closed. I just want to show you what is possible. But I think it won't work either. See, I can still pull it and it snaps back after some time. Because the pulling is more actual than the shutting. See, it flickers a bit and then tries to shut that. So, to make this safe, and you see, it's if I do that, the keypad will also just stay where it is. It's not going to go inside, and I can push it inside. So that's not a good option to do it. Not messing around with the transform. You could try to make it via the hinge, but in our simple level here, we will do another thing. We will neither need the hinge nor the door. We will go back to the editor here, and I will simply add another joint to shut the door. So don't need to do that. I take a ball joint from here, and then I just pull it over here next to this lock, to the pad, and now the safe is shut. It's like that. I go to the exporter. I am exporting to Teardown, and I've just overwritten my safe Lua import, so I have to do it again. Writing level safe.lua. That's a thing my editor can't do right now. It can't keep things in the XML while writing it. It will be able to do that in the future. But now we have that. I'm going to restart the level very quickly, and then if I'm going down, and I would just remember the right direction, I see I can't open the door and I can't close the door anymore because there is a joint here, and there is a joint here, and there's a joint here. That's the same principle as with the keypad. It's just locked right now. So what can I do? If the safe is opened with the keycard, I just delete this joint. And to delete it, I have to name it. And to name it, I need to know where it is, and I think it's the last ball joint I added here. I should have tagged it in the... I can do it. I go here, tag it like lock, export it again. Wait a second before I do that. Just copying the little script tag here. Export to Teardown, going here. Yes, then it's gone again. No problem. I write it back. And then I have the lock, I have the keycard and the keypad. So, guess what we're doing now? In our save lure, we're going to grab the lock with find joint, because we made it a joint, called lock. This will give us the lock we just created, the little red dot here at the door. And why do we need this? Because if the distance between the pad and the card is 0.1, then I say not keycard is near the keypad, I said save is unlocked. And then I simply delete the whole object. And what this does is it opens the save. Now this is a one-time solution, so I can't open it right now. Then I take the card, put it here. It says save is unlocked, and now the save is unlocked. You see, it works. I can't lock the save back, but for this kind of missions it's not important to lock the save back. If you want to really lock the save back in place, you can't just delete the joint like I did. You have to mingle around with the rotation of the hinge and see that the save is shut all the time. You have to do some tricks to do that. But for a one-time thing like opening the save, like I just did, you can do it just like that. Pick up the key card, save is unlocked, and you can open it up. Now one thing you should do is get this thing more immersive, and to get it more immersive you will have to have a click sound, which is just load sound, and then you can have a look at the sound library of Teardown. Here are the sounds, and maybe I need some, I don't know, tools, plastic, metal maybe, brake. Metal brake, why not? Don't think that's the right sound, but brake S4 is my sound. Click sound, and I will play it right here. And I will show you that we are not quite done yet, because there is one ingredient missing. Because every time the card gets near the keypad, which can be more than 100 times per second. You remember this function is called 100 times per second, and the card will stay in there for quite a long time. Every time then this message is given, the sound is played and the lock is deleted. Okay, the lock can be deleted only once. Lua doesn't care about that, but it will play the sound over and over again 100 times a second. So that's not so cool. We will see what that means. I can't open the save again, and listen to that. Oh, nothing, because breaks4.org. Did I mess it up, or is that sound so small that I can hear it? I take another one. I take the click up 0. Right? Click up 0. And this sound should play if the keycard reaches it. Sorry. As always, everything goes according to plan. There you hear it. In case you want to make a metal detector, you now know how to do it. Yeah, just make the keypad a door frame, and then check if this card is near the center of the door frame, and then play this. Play this. So the save is unlocked nonetheless, but I don't want that, so I just make one adaptation here. I say save is locked is true at the beginning, and if I unlock the save, I say save is locked is false, and then the condition here is if the distance between the card and the pad is smaller than 0.5 and the save is locked. Only if the save is locked do this, so do it just once. And this should yield the final state of this example. Click, you hit the little click, and the save is open. That's it for this small tutorial about interactive objects, about objects that interact with each other. You now know how to compute if something is near another thing, and what you do then. You can also delete the keycard, which is also a very... you can play around with the script. For example, deleting also the keycard when doing this, to not having waste laying around. And if you delete the keycard as well as the lock, you can see by using it, it is gone and the save is unlocked. It's a bit more immersive. Interestingly, it's a bit more immersive, and I can change the emissive value of this. Is another nice thing to close this, is to set the emissive value to 0. So I think I should set ME double M. No, set emissive value in the lightning lure. Set shape emissive scale. I hope it's for bodies too. Else I will grab the shape. So I say set body emissive. I don't think it's working with body, so I have to get the shape of the keypad, which is not the body, obviously. We can try that. So as you see, it's not open. It's not. It didn't vanish. So it's called set shape emissive value, and for that I can show you the last thing for this tutorial. I already have the keypad tag here at the body, and the Vox file itself can have a tag too, and I call it keypad shape. The keypad shape part, now where we are here, this is where we use find shape instead of find body. Keypad shape is this. And if this works, I can set the shape of the emissive scale of the keypad shape to 0, which should disable the lights. If it's not working, I will quit anyways. No, it works. Save is unlocked now. Which has a very interesting effect if you go to Magica and make it green. I think if I render this, yes, it should be white, all the way white, because it has no effect on that. I could add a red light source here again. I won't do it now. I will close this video in a minute. Close this tutorial, then we are at 40 minutes. That's quite enough. But as you see, it's nice to have a green open save. That's how you can make things interact with each other. I will make another nice tutorial in a short time where I show you how to use that together with BAM, get down to the ground, where you can use that together with nice cars and vehicles. So you can unlock and lock the car with the car key, for example, or where you can put something, where you can lock the trunk of the car to hide a suitcase in there, and then the suitcase is also locked, and you can need to open it up or something like that. You can chain those lock quests. I could place a smaller save inside the save, obviously, and then make the same thing over and over again. So you have to hunt for some keycards to open things, and another thing would be to find a combination and then to enter the combination here. I can show you that in another video. I hope this was useful for you. and I hope we'll hear and see us again, and I hope you have fun.